Hello, everybody, and welcome here to the Wine with Jimmy channel. Thank you for stopping by. So, my channel here is all about wine education, designed to help those of you who are studying the world of wine, or if you are just very interested in specific topics and disciplines spanning the wonderful world of wine. So I'm going to do a series here, and there's quite a few videos available of what's called explaining wine terminology. So this may be specific things you hear or read about or see on labels regarding wine, and what exactly does it mean? I'll go into quite great detail about each of these topics. This video is going to be discussing something called smoke taint, and we'll go through exactly what it is, what causes it, the compounds that we find within it, how to test for it, and the sensory analysis. So really, it's something I think which is gaining quite a lot of infamy at the minute. Lots of importance is happening with smoke taint due to climate change, and I'll also discuss that at the end of the video as well, why we should be discussing smoke taint. And in fact, it's going to increase only as the world becomes warmer. So if you do have a comment or question, please do get in touch. It'll be great to hear from you. Perhaps you live in a region, or you visit commonly a region which is affected possibly by smoke taint. Have you tried wines which have been affected by it? What are your thoughts and theories? So let's get cracking into the world of smoke taint. So first of all, what is smoke taint and what causes it? So when vineyards and grapes are exposed to smoke, this can result in wines with an undesirable sensory character, such as smokiness, burnt, ashy, medicinal. And these things, these sensory aroma and taste characteristics, are what we actually would call smoke tainted. They make the wine very unpleasant indeed. Now, of course, the conditions for smoke taint are caused by bushfires or wildfires that are increasingly common in warm to hot climate locations in the world of wine. But there are other ways that this can happen as well. Other minor influences may include something called stubble burning, which is a farming technique that involves setting fire to crop residue that remains after harvesting. Now, farmers do this to clear the field for the next crop and to avoid pests and diseases. But this is something which is in fact becoming increasingly controlled by governments around the world, as, of course, the environmental impact can be quite severe. So in terms of smoke taint, consumers have shown to respond negatively to smoke-tainted wines. Now, the compounds in smoke primarily responsible for taint are free volatile phenols that are produced when wood is burnt, such as, of course, forests and scrubland and even vines. Now, these can be absorbed directly by grapes and can bind to grape sugars to give glycosides that have a smoky aroma, for example. Fermentation, and this can be in barrel or bottle or in tank, these glycosides can break apart, releasing volatile phenols into a must or wine, and then, of course, increasing the perception of smokiness. And these glycosides also can release volatile phenols in the mouth during the drinking of the wine, which may contribute to what we experience as smoke taint. So, what kind of countries are we talking about in the world for smoke taint? Now, it's in multiple places because, unfortunately, wildfires, bushfires, are becoming exceptionally common today. So, the United States of America, Canada, Australia, Chile, South Africa, Spain, Portugal. Some of these are just naming a few. There are many others as well. And also, there's some evidence behind the importance of discussing this. If you look at the funding now available to wine regions, if we take for a case study in the United States, the Oregon State University, OSU, has received nearly $8 million grant to study the effect of smoke on grapes. And of course, you've only got to look at the Australian Wine Research Institute, who has been a pioneer and leader for this research too, with multiple amounts of funding. So here are your specific compounds. We've just kind of mentioned them briefly on the previous slides. So it has been firmly established that concentration of several phenols and their glycosides in the grapes and wines is firmly associated with the exposure of grapes to smoke. Now, these volatile phenols and glycosides can be used as marker compounds, or something we actually more often call markers, to assess whether grapes have been exposed to smoke by comparing their concentrations to natural background concentrations found in non-smoke exposed grapes. Of course, therefore looking at a control sample of a normal wine not affected by smoke taint versus multiple samples which have. Now, 7 volatile phenols are often tested, and they're listed there at the top of your screen. So this is guaiacol, 4-ethyl guaiacol, syringol, methylsyringol, O-cresol, M-cresol, and P-cresol. And then also 6 glycosides of volatile phenols. So we have syringol gentobiocide, methylsyringol, gentobiocide, phenorutinoside, cresol rutinoside, guaicol rutinoside, and methylguaicol rutinoside. So there are your glycosides at the bottom. Now, my knowledge on these specifically and my pronunciation is not obviously the best. I have done my research, but still, it does not come naturally to me. So please do look these up in your own time. Now, guaicol rutinoside was the glycoside which gave the best prediction of smoke flavor. And when all 13 smoke marker compounds were considered, it was guaicol and the cresols, along with guaicol rutinoside, cresol rutinoside, which were able to model smoke flavor very well, suggesting that these are our major compounds in sensory experience when it comes to smoke taint. So what about the risk factors then? We're going back to the vineyard, of course. The key factors that determine whether smoke-exposed grapes become tainted are really things along the lines of grapevine growth stage, the specific grape variety, the composition of the smoke, and the length of smoke exposure, as you will see listed here on the left-hand side of your screen. Now, on the right-hand side, I've actually given you an idea of how much of an impact smoke can have at different times of the grapevine growth and development. Looking at really, as you go down this list, from the kind of early stages of the grape coming through bud burst. So this is where you've got a lot of leaf foliage that is emerging, through flowering, through berry fruit set, bunch closure, veraison, and then up to harvest. And you can see that it moves from being low potential smoke in uptake all the way to variable to high. Now, we are generalizing here when we say that as the season goes on, there is a greater possibility of uptake of smoke taint, but there are always possibilities of smoke taint uptake across the season, the growth season. So it's important to think about that. So how does this happen then? Well, we know it happens on the vine. we know it's in the vineyard. So studies have demonstrated that the primary mode of entry for smoke-related volatile phenols into the vine and the accumulation in the fruit is directly through the bloom, which is the waxy cuticle on the berries, which is very important. It's actually mightily important in reducing transpiration through the grape, but it is also something which is quite waxy and can absorb many compounds within the local environment, including smoke taint. Now, when free volatile phenols enter the grape berries, glycoside-bound phenols are formed rapidly by biochemical reactions of the berry. When volatile phenols can be found in leaves, there is no significant translocation from leaves to berries of these volatile phenols and their glycosides. So therefore, it's important to note that there's no evidence of carryover from one vintage to another of phenols and glycosides. It is very much specifically localized within that season that the smoke taint will happen. So we've talked about the grapevine growth and development via that table on the right-hand side. Grape varieties and also the clones of specific grape varieties seem to differ in their sensitivity of the uptake of smoke compounds through terroir, and that could really be quite variable. There's been multiple studies, certainly in Australia, comparing the likes of Chardonnay, Pinot Noir, Shiraz, Merlot. And in some instances, the variety Pinot Noir tends to exhibit a lot more than others, depending on the clone. Another is smoke composition. This is important as it is made of particulate matter, secondary organic aerosols, and volatile phenols and other compounds. The exact amount of the smoke exposure will result in a perceivable smoke character in the wine, but we're not sure directly how much. So we know it's going to have some form of an impact. And this is because the chemical composition of smoke reflects fuel and combustion conditions and changes rapidly in the atmosphere, becoming lower in the concentrations of volatile phenols over time. So this means that smoke from recently burnt materials, woody materials, will contain higher concentrations of free volatile phenols and thus have greater potential to cause smoke taint in grapes and therefore in wine. And the density of smoke exposure can also be important, and this will be measured, but we are not too sure exactly how this will impact it in terms of research. So there you are, risk factors. When it occurs, the grape variety and clones themselves, and then the smoke, how it is composed, its volume, and the actual exposure. So how do we test? So if a smoke event through something like a wildfire has occurred, an option is to have wine grapes tested for the presence, of course, of smoke-related marker compounds like guaiacol and 4-methylguaiacol. The samples that can be sent to analysis to a lab can include grapes, juice, leaves, and wine. The testing of grapes and juice for the presence of smoke-related compounds of guaiacol and 4-methylguaiacol provides an indication of whether the fruit has been exposed to smoke. Low levels might be naturally present in fruit, but of course it's going to be much greater in those that are exposed to smoke taint. Guaiacol and 4-methylguaiacol detection in fruit cannot be used as a determinant of the smoke effect intensity in the final wine, as of course there are many variables which will happen from that fruit entering the winery and how it is processed, remembering that there are many chemical reactions which can actually increase the level of smoke taint. Now, the best thing to do if you are worried as a grape goer about the effect of smoke taint is really to send in some samples at the sort of 3-week point before harvest. Any earlier tends to be fairly ineffective, so it's better to do it a little bit later. And just a few things around how vineyards could be managed when they are affected with smoke taint, and then what can be done in the winery too if grapes are affected by smoke taint. So, luckily, there are a number of steps that can be taken in the winery and vineyard to minimize the sensory impacts, not to exclude or eliminate, but to minimize. Now, these extra processing steps certainly can lead to increased production costs, which may not result in a saleable wine when taken into consideration. So often you need to make a decision, a real executive decision in terms of, shall we just eliminate this fruit, sell it on, get rid of it, or do we make an attempt at making a wine? So what should be done in the vineyard? First of all, hand harvesting fruit. This will minimize breaking or rupturing of skins, and the process will need to be fairly speedy as well, but really maintaining that the fruit is intact to go into the winery. It's important to exclude leaves and stalks or any other foreign bodies that come into the vineyard, into the winery. And that's because leaves and stalks can further enhance the contribution of smoke-related compounds when in contact with the juice and in the ferments. We don't want more material to extract those compounds from. The integrity of the fruit, so the quality, so avoiding fruit maceration and skin contact with juice, as this can lead to higher extraction of smoke-related compounds. So really pulling it off the juice immediately, so utilizing free-run juice. Or in the vineyard, utilizing these quite clever techniques like activated carbon hoods that you see in this picture, which are very new in the last few years, which can protect the grapes from smoke taint by tying them around the grapes, which of course is a labor-intensive process. In terms of the winery, we should be keeping the fruit cool, as fruit that is processed at around 10 to 12 degrees Celsius will certainly extract less smoke-related compounds than fruit that has doubled that temperature. Whole bunch pressing, there's an example of the picture on the right-hand side. Whole bunch pressing has been shown to reduce extraction of smoke-derived compounds, particularly in whites, which it is common for. Then, being very closely in tune with the press fractions. So as the wine goes through its press cycles, making sure that the wine is continually assessed by yourself, so sensory analysis. And that is because as the press goes more intense in its pressure, it may start to extract more of those smoke-related compounds. There's also the possibility of conducting trials with fining agents. So fining with activated carbon can be effective at removing smoke compounds. However, the different products that are available to winemakers used of carbon, activated carbon, can actually also be variable in their effectiveness. So it's definitely recommended that carbon treatments be tested on small volumes of wine to determine the sensory impact. And then the further blending of carbon treated wine with non-smoke affected wine is another option, so blending in. One which is very much practiced in regions around the world affected commonly by smoke taint, sadly, is minimizing the fermentation time on skins. So reducing that skin contact, because that's where, of course, a lot of the smoke-related compounds are found due to the bloom. So potentially your reds ferment over 2 weeks normally. So you might only do half of that or even less than that to make a very delicate coloured Pinot Noir, for example. And then also consider trialing the addition of oak chips and tannin. There has been research that shows that oak chips can reduce intensity of smoke characteristics through increasing the complexity in the wine. Blending with non-smoke affected wine. Now, the level of dilution required to dilute smoke characters will depend on the concentration of smoke compounds that are found. But this is literally having some non-affected and having some affected, blending it together to try and blend out the problems of that smoke-affected fruit. And then finally, packaging and marketing the wine for quick sale. So keep packaging runs to practical volumes, pretty much to ensure that wines can be rotated into the marketplace quickly and avoid carrying the stock. That is because smoke-related compounds can often age with the wine and intensify through the studies that have been found. So it's an important way to mitigate that and get it into the market quickly and get it consumed quickly as well. Now, when vineyards and grapes are exposed, we know that the sensory effect is when we get things like smoke, burnt, ashy, medicinal, and that's smoke tainted. We know that consumers more frequently than not refer to this as a negative impact. Now, guaiacol and M. crisol, which are the top two in your table just here, certainly are major at contributing to smokiness or medicinal aromas, as well as sometimes being slightly tarry. So that's important to look out for. Also, O. crisol and P. crisol can add those too. I would say that the top two certainly are, you'll see by the sensory detection threshold in red wine and then in water, you'll see these are the lowest numbers. So guaiacol and M. crisol are certainly very much detected in wine, then P. crisol, O. crisol after that, and then down to 4-methyl guaiacol at the bottom. Syringol has a much higher sensory threshold, so it's less likely to have a sensory impact to the consumer. The volatile phenols can have a cumulative effect, though, so they're not isolated or mutually exclusive. So when several of these phenols are present below their threshold concentration, collectively, together, they can add up and contribute a medicinal or smoky flavor in the wine. I often find it actually a little bit like ashy, almost like when the smell, of course, is quite obvious. The taste is more like when you've had a cigar and you have that kind of ashy characteristic in your mouth. So the glycosides is guaiacol glycoside and then also M-cresol glycoside, which impart the smoky medicinal characteristics in the mouth, just to give you an idea. So there's some of the compounds that you may be experiencing. Just a word on climate change, of course. So climate change certainly contributes to more and bigger amounts of wildfires in a variety of ways. And as we know, the wildfires are the number one contributor to the smoke taint issue. The rise in average global temperatures has certainly led to higher spring and summer temperatures, and importantly, an earlier onset of spring across the world. This pattern has led to a rapid melting of spring snowpack, causing soils to dry out earlier and to remain dry for longer. After months of drying in the longer periods of higher temperatures, stressed forests have become more susceptible to things like infestations by bark beetles and and insects that certainly thrive in warmer conditions. Throughout places like the United States and Canada, these bark beetles have actually killed off hundreds of millions of trees and devastated forest lands, turning them into kindling, in effect, for catastrophic wildfires. Insect outbreaks killed more than 300 million trees in Texas alone in 2011, 129 million trees in California across almost a decade period, 2010 onwards. And that's according to the fourth National Climate Assessment released in 2018. Warming temperatures have also allowed populations of mountain pine beetles to explode at elevations and latitudes where winters were historically cold enough to limit their numbers. These insects have killed trees across 25 million acres in the western US since 2010. In California, the level of tree mortality has been so high that some areas report 70% of tree death in a single year. So we find that all of these conditions where trees are becoming very susceptible to different insect populations mean, of course, that there's lots more dry wood, which can result in much more severe spreading of the wildfires. Now, the west coast of the United States is particularly susceptible to a kind of weather whiplash. Wet winters fueled by atmospheric river storms originate in the eastern Pacific, followed by parched summers that are dry, and they dry out spring vegetation and transform it into kindling for wildfires in the fall. A 2018 study in Nature Climate Change predicted something like 25 to 100% increase in extreme dry to wet precipitation events. What this means really is that wildfires are becoming increasingly common, sadly, across many parts of the world, certainly in places like the western US, Oregon, and the United States of America, Canada, certainly with British Columbia, with the Okanagan Valley, South America, Australia, and the list goes on and on. Now, if you are interested in this topic, and you would like to actually discover much more information about smoke taint, its origins, the chemical compounds, what can be done in vineyards and in wineries, and then the impact on sensory, and then also climate change, you can find that information via a brilliant institute who has been, like I mentioned earlier, the pioneer, the leading voice in research of smoke taint. That's the Australian Wine Research Institute. Of course, this is done somewhat out of necessity, as it has been such a significant impact in parts of Australia. But that brings me to a conclusion for this video talking about smoke taint. If you do have any comments or questions, please do get in touch. You can do so by commenting on this video below. Make sure you click like and subscribe. If you do find yourself in the United Kingdom, please come and say hello for a class, a glass, or a bottle. I've been Jimmy Smith. Ciao for now. Goodbye.